Hi, welcome to the Anova Talk, a one-way analysis of variance, just the basics, presented by me, Tommy Cobb. Some terms to know that will be helpful as we go through the slide presentation are listed here on this slide. Assumption. Assumptions in statistics are normality and equality of variance. An assumption must be tested for verification of truth. Homogeneity of variance is an assumption of the independent samples t-test and ANOVA stating that all comparison groups have the same variance, or homoscedasticity. General linear model is a useful framework for comparing how several variables affect different continuous variables. And finally, p-value. This is the calculated probability of finding the observed or more extreme results when the null hypothesis of a study question is true. Within data sets live subsets. Some people may just look at a collection of overall GPAs and think, well, that's just, a bunch of numbers that don't necessarily mean anything other than the achievement of a GPA during a time of semester performance. Well, if you perform an ANOVA, you would be able to break up these GPAs perhaps by classification, freshmen, sophomores, juniors, and seniors. By performing the ANOVA within each group, you would be able to determine the mean or the average of all of the people within those groups. And then by looking at those subsets of numbers, you could perhaps determine that the freshman mean is 2.9, and that's the lowest of all the GPAs in the groups. Well, you might, in looking at that number, be curious as to why were the freshman GPAs average? Why was it so much less than the sophomores, the juniors, or the seniors? Maybe it's because they partied too hard. Maybe they weren't as focused. Maybe they didn't know how to study for sure. They might have skipped too many classes. But by using the one-way analysis of variance, you can find out whether or not there is a statistically significant difference in the means of GPAs by their classification. A one-way ANOVA tells the researcher whether the difference between the independent variables is statistically significant. Now, it can tell you that there are differences between variables, but, however, it cannot differentiate or distinguish which mean is different. To determine that, you would have to perform a post hoc test. You would use an ANOVA when you want to find out if there is an overall difference between more than two groups. We just use the example of GPAs within the classifications of sophomores, juniors, freshmen, and seniors. Another example might be you would want to look at feeder schools, maybe that all of these students formerly attended their high schools. You can see the differences in their post-secondary GPAs, perhaps based upon which feeder school those students attended. Remember that the question ANOVA can answer is whether or not the mean differences are statistically significant. There are requirements for the data that you would use to perform an ANOVA. Some of those are that you would have to have a dependent continuous variable, an independent categorical variable. They would need to have normal distribution, and there would be a random sample that would be taken from that population. Gather your data, making certain that the data meets the assumptions. Form your research question, identify the population that you're going to be studying, and then form your hypothesis. A null hypothesis would be that the mean of GPAs in all classifications are the same. And the alternative hypothesis would be that at least one of the means in the GPAs is different across the classifications. Perform your calculations and then determine the answers from those calculations. And based on those answers, you would either decide to not reject or you would fail to reject the hypothesis based on the p-value. And several things to remember about an ANOVA. It is fundamentally about mean differences. A one-way ANOVA tells the researcher whether the difference between the independent and dependent variables is statistically significant. An ANOVA can determine that there are differences between variables, but it cannot differentiate or distinguish which mean is different. And you would use an ANOVA when you want to find out if there is an overall difference between more than two groups. I'd like to leave you now with a list of just a few resources where you could find additional information about